All right, I'm just going to run through some stuff on percentages. If you're happy with your maths and you're confident with it, you probably don't need to do this. But I know for a lot of people, when they get to calculating percentages, it comes up a lot in biology. Some kind of panic sets in and they're not sure what's going on. And all kinds of things go on. So I'm just going to go through some stuff on percentage. This will particularly help you as well with the Hardy-Weinberg stuff, Hardy-Weinberg formula, where we seem to be working with percentages and decimals. It's not always clear what's going on. So let's just look at this. Now, the first thing I'm going to suggest is, before we get to the percentages, is just using a calculator. And you might say, well, I know how to use a calculator. But let's just use an example of working out an average or a mean average. So let's say I've got three numbers here. I'm going to say 7 plus 8 and 10. Okay. So what's my mean average of 7, 8 and 10? I add them together and I divide by 3. So if I say 7 plus 8 plus 10 is 25, and then I divide that by 3 because I've got 3 values, by 3 equals 8.33. Okay, now why am I going through all this? By the way, a little point here, although the value you can see there is 8.3 recurring on and on, we don't use recurring decimals in science. The numbers we're usually working from are from experimental measurements, and you can't go on to, you can't say 8.333333 because you're limited by the equipment you use to measure. So don't fall into traps of putting sort of 8.3 recurring. Round it off. Usually you would round off to one more decimal place than the data you used. So here I've gone sort of 10, I'm calling it 8.0, 10.0. I've gone to one more decimal place. That's usually a safe bet. If you're in any doubt at all, go to 2 decimal places. But you know, the rule is, if you go to 1 decimal place more than your smallest value. Okay. Now, why am I blabbing on about working out mean averages? Well, if you did it like this, if you went 7 plus 8 plus 10, and then you didn't press equals, you just went divided by 3, you get a completely different value. And the reason is because of BIDMAS, brackets, indices, division, multiplication, addition, subtraction. So what I've done in this second version is effectively that, which gives me a completely different value. So do be careful when you're doing calculations that you're aware of this. Go through each bit carefully, step by step by step. That's one of the first places people make mistakes. Okay, percentages. Now I'm going to start off by using quite a simplistic value. So let's say 50 is what percentage of, and I'm going to use a total of 200. So if you were asked, I know there's a sample of, I know 200 snails and 50 of them have got a particular a stripy shell, and it said what percentage of the snails have got a stripy shell. Now you might be able to work that out in your head anyway, but we're just going to go through the whole process. The way you do it is you would take the number you want to work out and you would divide it by the total number here, and then you multiply the whole thing by 100. So let's do that. 50 divided by 200 equals, and then multiply by 100, and lo and behold, our value is 25%. And you could probably have done that in your head. 50 divided by 200, and you could have gone, well, it's a quarter, it's 25%. Okay, let's try a different one. Let's say, well, what's 75 out of 200? So 75, sorry, 75 as a percentage of 200. Well, it's the same thing. You just go 75 over 200 this time, times 100. And let's see this one, 75 divided by 200 equals 0.375, times it by 100 equals 37.5. Now, there's an important point here. If I look at this value, 25%, and if that was for 50 if it's 25%, 75 has got to be a bit more than 25. It's got to be a high percent because I've got a higher number here than here. And look, it is a higher number. It's very worthwhile making an estimate first of all. So, you know, what would 50% of 200 be? 50% of 200 would be 100. You know, if you want to work it out, it does work. to go through the whole thing, just step by step to show you. 100 divided by 200 equals times 100 is 50%. Okay. 75 is less than 100, but more than 50. So the value is going to be halfway between. Okay. So making an estimate of where you think your percentage is going to be will help, because again, a lot of people make a mistake where they put a wrong number in, they do something wrong at this stage, and because they haven't estimated, they don't pick that value up. Now, here's where it gets a bit cleverer. Let's just go back to this one for a second. So we said 75 divided by 200. Now, if we just leave it at that stage, that value there, 0.375, before we multiply it by 100, we can actually look at our percentage instead of being a percent like this, and we could express it as a decimal. So 0.375 is 37.5% as a decimal. Now, if that's confusing, think of it this way. If you think of 100% being represented as 1, what would 50% be? 50% would be half of that, it would be 0.5. What would 25% be? 0.25. What would 12% be? 0.12. What would 3% be? Here's one that people get wrong, 0.03. Okay, so you can express your percentages as a decimal like this. And again, if you want to double check on it, if you said, let's invent another number, let's say what's 50% of 30? And you might be able to do that in your head. You just go, well, it's 15. But that's the same as saying 30 times 0.5. Just to prove it, 30 times 0.5 equals 15. Okay, so you can use this decimalized version quite easily. If you say, what's 72% of 96, it's quite easy. You go 96, and you multiply it by, rather than 72%, 0.72. Okay, and the answer is 69.12. Now, notice here how I'm changing between the numbers and percentages. Make sure you keep an eye on which one's which. All right. Now, the other thing we can do with this method is just go back to this formula here. What's half, or what's 50%, or what's 0.5 of 30? Okay. I'll rewrite it out as you purple. So the way we worked out what half of 30 was, we did that. Okay. But let's imagine that we don't know what this value is. Let's say let's use 30 again, and I said let's pick 17. 17 is what percentage of 30? Let's call it Y. Why not? So we don't know what Y is. Okay. So 17 is what percentage of 30? Well, using my estimate, I know that it's going to be a bit higher than 0.5, maybe not too much higher, but let's see if we can work it out. Now, again, if your algebra is up to this, you probably know how to do it already. If your algebra isn't up to it, well, just trust that this method will work. Because I've got a nice straight linear equation here, straight formula, it's quite straightforward to change it round. What I want is to get this Y on its own. How do I get rid of the 30 times? I divide everything by 30. So I do that, and I do that. 30 on the top and 30 underneath will cancel out. Get rid of that. So I'm left with my unknown value, my unknown percentage is 17 divided by 30. Let's see what happens. 17 divided by 30 equals 0.566. So let's round it off. 0.5. I'm making mistakes now. 0.57, which is the same as saying 57%. Does that sound right? Well, remember I said that 17 is going to be higher than 15%. 15 was half of it, or 0.5. So 57% 0.57. Yeah, that sounds about right. I've worked out my percentage.